Good morning, everyone. I trust you're all doing well. Before I begin, can I please just get an indication of whether you are all able to see my screen? Okay, thank you. I see a few thumbs up. So with that, I will be starting today's technical session. So welcome to today's technical session where we will be discussing the analog inputs and outputs of the GOC43. The topics which we will be discussing today includes the analog options you have for your GOC43, as well as how the I/O mapping works, how to configure the analogs, and ultimately how to program your analogs. So when it comes to your analog I/O options, you have both a built-in analog input, so you have two built-in analog input channels, as well as two I/O slots for an extension modules. So you have two slots, meaning if you are already using another extension unit, you will only be able to add one more, or if you already are using two of the slots, you won't be able to add analogs. So that is something you need to keep in mind when you want to use analog extension modules. So your analog extension modules can include both or inputs, outputs, as well as a combination module. Starting off with your built-in analog inputs, as I mentioned previously, you have two channels available, and these inputs, built-in analog inputs, support both voltage and current inputs, but only 0 to 10 volt and 0 to 20 milliamp inputs. The built-in analog inputs are of 12-bit resolution or 12 bits, so your digital value will range from 0 to 4000. And last thing about these specs, engineering scaling is supported and can be configured within CODESYS. They are quite there's quite a bit more information regarding the specs of both the analog inputs, built-in inputs, and your extension modules, which you are able to find in the GOC43 manual if you wish to do so. So when it comes to wiring, it's rather straightforward. This is your voltage input, and this is your current input. And once again, all of these wiring diagrams are available within the manual. Now, when it comes to your extension modules, as I mentioned, we have output extension modules, input extension modules, as well as a combination extension module. For your output extension modules, you have 3 modules available, all practically exactly the same module, with the only difference being that you have a 1-channel module, a 2-channel module, and a 4-channel module. So that the 1-channel module would be the first one, the 2-channel module, second one, and the 4-channel module, the third one, right here. Now for your input extension modules, your options, you have 3 options. The GC-4 UAD-10, these module with a E, and then GC-4 UAD-16. These modules tend to have more input types than your built-in analogs, especially because they can take temperature input types, but we will be elaborating on that in further slides. The combination module you have available for the GOC is the GC4A-12. Now, just something to point out, the general naming convention of these modules, the number you see right here, so the number you see here generally indicates the amount of channels the module has, where your DA says digital to analog conversion, and AD is analog to digital, and if it's just an A, it's a combination module, whereas the last number indicates the bit resolution, so whether it's a 0 to 4000 digital value, or a 0 to 64 or 32 or what have you. So with that being said, let's move on. Let's start with the output modules and the specifications. As I mentioned, these three modules have basically the exact same specification, with only exception being the number of channels available for each of them. So you have the 1, 2, and 4 channel, and these modules can take both voltage and current output types. The types being 0 to 10 volt, minus 10 to 10 volt, 0 to 20 milliamp, and 4 to 20 milliamp. This is a 12-bit module, or channels. The channels are 12-bit, so your digital value will range from 0 to 4000, and in the case of the minus 10 to 10 volt, it's minus 2000 to 2000. For this module, you also have, or these modules, you also have engineering scaling available that can be configured within the engineering software. Now, when it comes to wiring for these modules, all three have these same wiring diagrams, but the difference being, once again, the amount of channels they have available. So as the 2-channel and 1-channel module only uses or uses less channels than the 4-channel module, the top terminal blocks are unused for these modules. Same for the 1-channel module. Only the first 3 terminal points are used on the lower terminal block for this module, whereas for the 2-channel module, the entire terminal block at the bottom is used. So we now start with our analog input options. This is the GC4UAD-10 or the -10E. Now these modules are essentially, once again, the same module with basically the same specifications. The exception in this case is one of the input types. So both of these modules are 4-channel modules with input types voltage, current, and PT100. So it can take a PT100 sensor, with the voltage being 0 to 10 volt, current 0 to 20 milliamp, and here's where the exception comes in. So the 10-10 module can take a PT100 with a temperature range of minus 50 degrees Celsius to 150 degrees Celsius, whereas the -10E module can take a PT100 with the temperature range minus 50 degrees Celsius to 450 degrees Celsius. This is once again a 12-bit input channel module. However, if you recall, I mentioned that the last number generally indicates the bit or the digital value range. For this case, the 10 actually refers to the predecessor of the GOC43, which is the GOC35, for which this module is a 10-bit input channel module, but for the GOC43, it is a 12-bit module. This module can also be configured for scaling in your engineering software. Now, these 2 input modules are slightly different than your other modules, and that is with the fact that you use dip switches on the physical module itself to configure the input types for each of your channels. Now, as you can see on the image on the left, there are 2 rows of dip switches, 8 dip switches per row, with the first row being numbered from left to right 1 to 8, and the upper row or the second row also being numbered left to right 1 to 8. So that means both rows are numbered 1 to 8. Each channel has 4 dip switches, And these dip switches, depending on whether they are on or off, configures a input type. Now, your dip switch configuration does not mean that you don't configure your input types within CODESYS. You still need to do that, and your dip switch configuration needs to match the configuration in CODESYS. Otherwise, there is case or there's certain settings, or not settings, outputs that will be output in the case of a mismatch or invalid setting, which is highlighted in the GOC manual on pages 111 and 120. So these just show you what the channel values will be in the case of a mismatch or invalid setting. That kind of gives you an indication on what might be wrong, why your channel or your module is not working. So as I mentioned, as you switching the dip switches on and off configures them for different settings. So as you can see, here's the layout. The top row 1 to 8, the bottom row 1 to 8, 1 to 4 channel for the bottom row is channel 1, 1 to 4 for the top row is channel 3, 5 to 8 for the top row is channel 2, 5 to 8 for the bottom row is channel 0. So when you look at the table above, when let's say channel 3, you want to configure this module for, or this channel for voltage input, you need to turn on dip switch 3 of the top row. So if I show you there, so we need that one on, which it now is. And this is how you would configure your different switches. So for instance, if I want to have channel 1 be a 3-wire PT100 configured for the 3-wire PT100, I would turn on dip switch 1 and 2 of the bottom row, which are these two. And the same applies for all 4 of these channels. For instance, if I want to do current for channel 2. So this is how you would configure the dip switches to reflect a certain input type. When it comes to wiring, the wiring for the 2 modules are identical, with this being an example of your PT100 wiring, and this being your voltage input and current input. Now note your channels 1 and 0 to 1 on the bottom terminal, whereas channels 2 to 3 are on the top terminal. Now here are just some recommendations for wiring your analogs in general. For the GOC43, the recommendations in the manual are to use 2-core shielded twisted pair cable, and to connect your shield at the IO extension unit end as opposed to the sensor end, and to keep earthing resistance less than 100 ohms. Now this applies to all the analog modules for the GOC43. Now our last input module is generally by far the most diverse, or has the greatest versatility, has the greatest amount of input types of our analog input module options, because it can take all of these input types, which is 0 to 10 volts, minus 10 to 10 volts, minus 100 millivolts to 100 millivolts, 0 to 20 milliamps, 4 to 20 milliamps. It can take a PT100, a PT1000, a J-type thermocouple, as well as a K-type thermocouple. And this is a 16-bit input channel module. So the range is from 0 to 64,000, or minus 32 to 32,000. Now, one thing to note, and this actually also applies to all the temperature inputs. For the temperature inputs for any of the GOC43 analog extension modules, temperature inputs cannot be scaled by the user. It is actually automatically scaled by the PLC itself, whereas your voltage and milliamp inputs, the user can define a scale. Here's just the wiring diagram for the module with an example of your voltage input, current input, thermocouple input up here, and your PT100 and PT1000. Once again, your channels 1 and 0 are on the bottom terminal block, and channels 2 and 3 on the top terminal block. So for your temperature inputs as well as your 4 to 20 milliamps inputs, you actually also have a open circuit detection available, and the value reflected in the case of this error can be configured in CODESYS. Now, our last module, which is the combination module, so the input and output module, has 2 input channels and 2 output channels. Starting off with the input channels, they can take type inputs, input types, voltage and current, 0 to 10 volts, minus 10 to 10 volts, 0 to 20 milliamps, and 4 to 20 milliamps. The 2 input channels of this module are also 16-bit, so they also have a digital value of 0 to 64,000 or minus 32 to 32,000, and the values can also be scaled. When you get to your analog output, this is it also has the same output types as the input channels, so it also has minus 0 to 10 volts, minus 10 to 10 volts, 0 to 20 milliamps, and 4 to 20 milliamps. But the difference being that your output channels are only 12-bit, so they only have a digital value of 0 to 4,000 or minus 2,000 to 2,000. And when it comes to your physical wiring or the layout of your module itself, your output channels are on the bottom terminal block right here. So channel 0 and 1 for your output channels are at the bottom, and your input channels are at the top. So they are also labeled channel 0 and 1, but input channel 0 and 1. With that being said, we will be moving on to our I/O mapping for both your built-ins and your extension modules. Starting off with built-ins, so the values or variables associated with your built-in analogs form part of your IEC variables, which is a group of variables that is known by a symbolic name, which in this case is underscore base underscore analog, and then within that group you'll find different variables that pertains to your built-in analog. 2 of these variables being the channel data, so the digital value, the variable wherein the digital value is stored, which is underscore AI underscore data underscore 00 for channel 0, and 01 indicates it is for channel 1. There's also a variable that is used for your channel status, and this is a array. So position 0 of this array will indicate the status of channel 0, and position 1 of the array will indicate the status of channel 1. Now the word, the bits in the word indicate different things, which is broken down in this table. So if bit 0 is disabled, is 0, then the channel is disabled, and when it is 1, your channel is enabled. If bit 1 is 0, then the channel configuration is valid, and whenever the bit is on, the channel configuration is invalid. The channel input data is out of range, so bit 2 indicates whether your channel data is out of range, with 0 indicating that the data count is valid, and 1 indicating that it is invalid. Apologies. For bit 3, this indicates whether there is a open circuit or short circuit detected. These are the only bits that are used within this status word, with bits 4 to 15 being reserved. Now, as I said, those variables are IEC variables or part of the IEC objects. Now, for the analog extension modules, there's also a set of variables that are available within the IEC variables. These start with the prefix of IOE and then whatever number IO slot. So you'd have IO slot 1. So if your analog input or output or analog module is installed on IO slot 1, the prefix will be IOE1, whereas opposed to if your module is installed in IO slot 2, it will be IOE2. Now, these variables of the extension module that form part of the IEC variables, they hold the channel data as well as some status data or variables as well. However, there's a second category of variables for your extension modules, which are your IO variables. So the difference between these and your IEC variable for the extension modules is these have physical addresses assigned to them, and the variables that you have for the IO variables are a status word and control word, which are used to enable your channels and monitor the status of your channels. So every module actually has its own set of variables within these two categories, and where they are largely the same, they do differ from module to module. So I will be going through one or two of these options just to give you an idea of how or what information is stored in these variables. Now, all of this information I'm going to show you now is once again in the GOC's manual, which you can download from this website following this link I have right there, which you should be able to follow once I give you the presentation after our session today. Now, let's start with the output module. So these, the first two tables are your IEC variables that are available for your output modules. All of these output modules, once again, have the same variables. It's just the channel count that differs. So for a one channel module, you won't have a variable to store channel 1, 2, and 3's data, and so forth. So the variable that stores the channel data, so the digital value, is this one right here. So underscore AO, which indicates it's analog output, underscore IOE, underscore data, and then position 0 in this array. Yeah, and it will store this digital value, and the digital value range will also depend on what input type you have configured. And this applies to all of the channels. Just to note, whenever you do enable engineering scaling, so in CODESYS, if you do select scale and you give it a value, this variable will reflect the scaled value and not the digital value you see here. So the other variables within this the IEC variables are a channel status variable, which, similar to what the input built-in inputs had, indicates whether the state channel is enabled, whether the configuration is valid, whether your input data is out of range or not, and whether you have open circuit or short circuit detected. You have a second status variable. This generally indicates more to the module itself as opposed to the channels. As you can see, this is channel status and this is unit status, which once again, similarly to the channel status, each bit in this byte or each value reflects a specific status. So when the value of this byte is 0, it says no unit is fixed in the IO slot, so it's not detecting a unit. The CPU is not detecting a unit on the physical GOC. 1, if the value of this byte is 1, there's a mismatch between what you have configured and what is actually installed on your GOC. And 2, the unit is detected, and it is in the configuration state. And whenever everything is correct, so configuration is valid, unit is correct, and everything, you should see value 100. Now, those are your IEC variables. Apologies. These are your IEC variables. Now, moving over to your IO variables. Now, as I said, these are the variables with the physical addresses. They also indicate these are actually used to enable your channels. Also, they indicate some statuses of your unit. So for the output channels, as I mentioned, if this is a one channel module, you'll only have the option to enable one channel, channel 0. If it's a two channel module, you'll only be able to enable channel 0 to 1. And for the 4 channel module, obviously you'd be able to enable all 4 channels. Now, these are used to enable your channels in your programming itself, where your control word is the feedback to show that the channels are enabled. So that is the variables for your output modules. I'll be going to the GC4UID-16 for the input module variables, although there are some differences between this and a -10E module, or -10 and -10E modules. So once again, for our IEC variables, we have the variables that store the channel data, which are these from 0 to 4, as this is a 4-channel module. And once again, this will store the channel data, the digital value for the input type. And as I mentioned previously, if you have engineering scaling enabled, your values for the milliamp, millivolt, and volt inputs will reflect the scaled value as opposed to the digital value. But for the temperature input, so the PT100s, your PT1000, and your J and K type thermocouples, it will reflect the automatic scaling that the GOC already has for it, which is this range you see right here. Now, there is position 4 and 5 of this array also holds your CJC, so data for some error checking. Apologies. So you also have a channel status variable, as we did with the output channel. And once again, this holds whether your channel has been enabled, configured, whether there's a sensor fault, and so forth. The unit status once again indicates whether the correct unit is installed on your GSC, whether the configuration matches the unit installed, and whether your unit is in a running condition. These are once again your I/O variables for your input module. Now, once again, you have your enable variables, so IOE, whatever this slot this is in, and then enabling this enables the channel. And this indicates whether the channel is enabled, the control word now. Now, similarly to this, your combination module, which is this one right here, also has these variables. Obviously, they just have a version of input and output. So for your input variables, it would be AI, and your output AO, with channel 0 of the inputs being in position 0, and channel 1 of the inputs being in position 1. Same with the outputs. These are once again your variables that hold the channel data, with the next two variables being those that have your channel status and your unit status. Once again, this is very similar to the previous modules I have explained, where this just gives you some information on whether your status, your channels and unit are configured correctly. Once again, you have your I/O variables for this module, with two of them once again being your output enable and two being input enable to output enable, apologies. And it also indicates whether there are faults. Like for your outputs, it will indicate whether there is a 24-volt supply or not. You also have your control word, which once again just gives you a indication on whether your channels are enabled. Okay, so we will be moving on to configuring these analogs in CODESYS. So I will be switching over to CODESYS for the rest of this presentation. However, most of the information I will be giving you now is in this presentation, in these two slides or sections. So I've already created a project for today, and I've already set up my PLC settings right here. Note if these PLC settings are not correct, so if you don't select these exact settings as is recommended by the manual, the analogs will not work. So starting off with our built-in analogs, to configure them, you need to open this device editor window, which I just did. So this is located in your device tree right here, and double clicking on this opens this window, and going to parameters and configuration, and then selecting analog input. This is where you are able to configure your built-in analog inputs, and you can see there's a tab for channel 0 and a tab for channel 1. So when you are on channel 0, the tab for channel 0, you are able to configure your analog input, built-in analog input. So firstly, to be able to configure it, you need to be able, or you need to first enable this channel. So enabling this channel will allow you to use this input channel. So you can configure your input types, which if you do recall, your input types for your built-ins are 0 to 10 volt and 0 to 20 milliamps. You can set a filter, or you can say no filter, so you can either choose between your averaging or digital filter. And when you select, for instance, the averaging filter, you can select the value or the amount of samples to average. And for instance, when you do choose a digital filter, you can choose the filter time constant. For this, I will just be choosing averaging, and here's where you are able to enable scaling as well as set the range for your scale value. So if I select this checkbox and enable my scaling, the apologies, the channel data, so the digital value will now reflect the scaled value and not the 0 to 4000 digital value. So that is how you configure your built-in analogs. And for every channel you want to configure, it has its own tab, so you need to configure this as well if you want to use both channels. When it comes to configuring your extension modules, you first need to add your extension modules to your hardware configuration. So that is found in the device editor window when you go to hardware configuration. So to be able to configure your analogs, as I said, you need to add your modules. So the GOC knows what variables to use in this case. So for my configuration, I actually currently have the, let me just track this here, this GC-4UAD-16 module on my GOC. So adding this module in your hardware configuration allows you to configure the module. So you'll see in the device tree under IO extensions, it now no longer says empty for slot 1. It now indicates that there's a module there. So when I double click this, I can open up the window in which I can configure this module. So as you can see here, I have channel 0, 1, 2, and 3 in these tabs, each of which opens a different screen for configuring that respective channel. Now, you'll notice one thing that's a bit different from the built-in analog input configuration, and that is, let's go here, that is the enable checkbox. So there is no enable checkbox for the extension modules. That is actually why you have your IO variables. So those variables with the actual addresses are used to enable your channels as opposed to a checkbox as you have with your built-in analogs. So similarly to the built-in analog inputs configuration, you can choose your input type, select what filter you'd like to apply. Let's say, once again, this, and whether you want to scale your value. Now, what I currently have on my setup is I have a 4 to 20 milliamp sensor on my channel 1. Which I want to scale from 0 to 100. And I am fine with a sensor fault value of 0 when that is the case. So your sensor fault or open circuit value, this is the value that you want stored in your channel data variable when, in the case that there is a sensor fault or open circuit. So this is only applicable to the 4 to 20 milliamps and your temperature inputs. If you see, if I go to 0 to 20 milliamps, I am no longer able to configure this. Same with if I go to millivolts or volts. So, okay, so that is my 4 to 20 milliamps input. I also have a PT100 with the range of -50 to 250 degrees Celsius on my second channel. And the rest I will be leaving as such. And then on the third channel, I have a K-type thermocouple wired. So just as an example, I will quickly just add a output module to the configuration to show you how that configuration looks, but I will, before downloading the program to my GOC, I will be removing it, otherwise I will be getting errors. So to do that, let's quickly go back here. And let's add the 4-channel output module. So now I'm able to configure this module, and you can see you have quite a bit less options, but you can configure your output type as well as your scaling right here. So it's quite similar. It's quite easy to configure these modules actually. So you have your channel 1, 0, 1, 2, and 3. So that is how the output modules configuration looks. And let's replace this module with the combination module. And you'll see that actually it uses the exact same screens as your inputs and outputs. It just has a separate tab that indicates analog input, channel 0 and 1. As you can see, this configuration screen is similar to the input channel modules we were just using. And when you select the analog output, you also have an option of channel 0 and 1. So remember, these are 4 different channels. So configuring channel 0 here and configuring channel 0 here are 2 completely different channels, because one is input, one is output. But yeah, it's as simple as that to configure your analogs. Now, when it comes to the actual programming needed, is actually not much. So for my built-ins, I don't need to program anything. I don't need to enable a bit to enable the analogs, because everything is done within your configuration itself. So everything is done in here. However, when it comes to your extension modules, as I mentioned, these IO variables are used to enable channels, because you don't have that tick box for extension modules. So this you will have to do within your program. So the easiest way for me is to generally use a always on bit. So for the GOC, that is in our system variables. So that is sys for CPU dot system bits, and need to remember it's .0. Come on. That's my mistake. So that is my always on within the GOC, and just using this to turn on my channels that I want to be turned on. So to find these variables, so your IO variables for your extension modules are within IO config globals mapping. So this is where you'd find your enable or channel OK variables, which for us, for my setup, I want channel 1 enabled. Let's So I want 3 channels enabled. Let's just do this. So once again, that was channel 1 I enabled. Now I want to enable channel 2, which is this one. So you can see it's an IO slot 1, and this is channel 2 enable. And the same for the 3rd channel. So that is actually all the programming I need to have my analogs working, although obviously you can use the channel data within your program. And to do that, let's just show you where you can find the respective variables, which you can use to troubleshoot or just use the channel data in your program. So for your built-ins, this will be base analog, so it's under IO config globals, not IO config globals mapping. So base analog, you'll find your channel status as well as your AI data. Once again, your data is your channel data. And when it comes to your IO or your extension modules, the IEC variables will be under IOE and whatever slot it is installed in, so IOE1 for this case, and you'll see the channel status and data and unit state variables in this when you expand this. Whereas the IO variables with the addressing, so yeah, that's the difference you'll actually see here. If you look under the address column, you can see the IEC variables don't have physical addresses, they are purely symbolic variables. Whereas my channel enable and channel OK variables are assigned physical addresses. Now these addresses, the address range is actually assigned to the IO slot. So slot 0 uses input word 12 and output word 12. So that is percentage IW12 and percentage QW12. Whereas my second IO slot uses input word 13 and output word 13. Now when you want to see your variables or where you can monitor your variables, I will show you when we are online as well. But for your built-ins, when you go to your device editor window and IEC objects, you can see base analog here. So when you are online with your GOC, you can actually monitor the different variables within this variable group, which I will be showing you in a moment. And for your extension modules, there is a IO mapping tab. So that is your IO variables. So your status word and your control word. And as I mentioned, it is output word 12 and input word 12 for IO slot 1. So when online, you'll be able to monitor these variables in this window. And for your IEC variable or object, which is your channel data, you just go to the IEC objects tab within your extension module window. Now, to demonstrate this, I can quickly download this program to my GOC, and I'll also be able to show you the values of my inputs. Okay, wait. I'm gonna board quickly. Just need to check. I don't actually have anything wired in my built-ins right now, so I will just be disabling them, otherwise I'll be getting errors. As for the others, it should be fine. That changed. So my program is now downloading to my GOC. So I show you where you can view the variables, but you can also obviously use your watch window to monitor the values, your channel data, even your statuses. So I will be showing you how to do that in a moment once we are online with our GOC. You can see my program has finished downloading, and when I put it into run mode, the channels will enable, as you can see right there. So to use my watch window to see what my channel variables currently are. So once again, my channel data is in IO config global. And when I choose this, I need to indicate what channel. So we have channel 1, and there you can see a value currently being input. So once again, this is my 4 to 20 milliamp input. And if we want to see the other channels, let's say channel 2, which has the PT100 wired, you can see my input. So if you do recall, I set up scaling from 0 to 100 for my 4 to 20 milliamp, but I can also show you how it would look if you just have your digital value. So once again, whenever you have scaling enabled, the scaled value does replace your digital value in this variable. If you do not have scaling enabled, this will actually reflect the digital values, so 0 to 4000 in this case. No such thing as 31. Okay, so those are my three inputs I currently have wired on my GOC. So just as an example, let's look at channel status of channel 1. You can see currently it is 1. Now, if you recall, whenever bit 0 is enabled, that means the channel is enabled, and if all the other bits are off, it means the configuration is valid and there is no sensor fault. And last but not least, unit state, it should reflect 100 because the unit configuration reflects what is on my GOC and the unit is in a running state. Now, checking the IO variables right here. If I go to the channel 1 OK, it should be on because it shows that my channel 1 is enabled. For instance, if I go to channel 0, it should indicate that that channel is not enabled. And let's just so channel 0, okay, should show false, which it does. So I mentioned previously you can also monitor these variables here. So this page now looks different because you are online with your GOC, which if you look at your base analog and expand that, you will now be able to monitor these values. Currently mine is 0 because I do not have anything wired to my built-ins, but this you can see right here. And when it comes to your extension modules, you can also monitor your variables directly from this page right here, and this one as well for your IC variables of your extension modules. So you can see these values actually also reflect this. So one last thing I would like to do is when I change channel 1 to no longer have engineering scaling, I'd just like to show you the difference in the channel data. While we are waiting for the program to download to my GOC, are there any questions regarding today's session thus far? If so, feel free to type your questions in the chat. So yes, it is you are able to have analog inputs, but that is if you do install 2 modules on your GOC, and that also stops you from actually having a other module installed. But yes, you are actually able to do 8 modules, analog channels, input channels on your GOC. As for the engineering scaling question, yes, that is correct. It is. So how do I put this? So as you currently see here, as I mentioned, the input channel, the value is stored in a 16-bit register. So this value can range from 0 to 64,000. So the value, the analog value that comes in is converted to a value from 0 to 64,000. So whenever you add scaling, it takes the value out of 64,000 and scales it to the range you want it to be scaled to. I hope that makes sense. So if you do see the change in my channel 1 data, it now is a value of 22,180. It kind of jumps around a bit, but it's no longer a value of 30, I think it was 34 or 31 previously. And that is actually the end of today's session. Are there any more questions regarding today's topic? So while we are waiting, the next session in the GOC series is regarding data logging and how to set up your GOC as an FTP server, and this will take place on the 27th of August in the normal time slot of 10 to 11:30.